Welcome to this Getting Started guide for the Hirschmann IT MTS product range. I'd like to mention right at the beginning that this is not a technical training course. Comprehensive technical training courses are available from Belden and also from our partners. In this series of configuration examples, I want to show you how to configure some basic functions on the MTS switches. If you are deciding whether to evaluate the MTS switches, these examples will give you an overview of how the functions can be configured. If you already have an MTS switch, you can follow these examples step by step to configure your devices. All switches in the Hirschmann IT MTS range have the same user interface. For these configuration examples, I'll be using an MTS 2624. This is the smallest switch in the product range, but it has a comprehensive feature set at a very low price. I have this switch as part of my demo equipment because it's small, light, and very importantly for me, it's quiet. I'm not planning to use PowerPoint slides during this demonstration, but I just want to explain a couple of things before we start, which will speed up your understanding of the demo. First, the structure of the command line. Like many other network devices, the MTS command line interface is divided into several command modes, each of which serves a specific purpose. Common user mode is the default mode when you first access the device. It provides limited access to basic monitoring commands. It's used for viewing statistics and performing basic network tests. Privileged user mode provides full access to many commands, including those for configuration and management. It's used for viewing and saving configurations, debugging, and accessing other modes. Global configuration mode is used for making changes that affect the entire device. It's used for configuring device-wide settings like hostname, passwords, and global features. Interface configuration mode is a sub-mode of global configuration mode. It's used for configuring interface-specific settings like IP addresses and status. There are other modes, but these are the ones we'll use for the demo. If you're not sure which mode you're in, just look at the CLI prompt. Next, some useful commands. The most important ones are the question mark for online help and the up arrow to repeat previous commands. I'll just say a quick word about your terminal emulation software. Over the years, I've used many terminal emulation software packages, but today I'm really satisfied with Terraterm. Some programs require you to use unfamiliar key combinations to move through the command line. Terraterm works fine with the standard keyboard keys. It's my personal preference, but not a recommendation. Last slide before we get started with the demo. Some demos and even tutorials concentrate on how to use a product's user interfaces, but they don't show each function actually working. I like to see a function working to be sure that I've configured it correctly. So, for each example in this Getting Started guide, I'll also show you how to test the function. I'll do this using free-of-charge software applications. These are the applications I'm going to use and the links to download them. So let's get started. In this demo, we will primarily look at the MTS switch command line interface. Like most IT switches, the CLI is the primary configuration interface. All functions of the switch can be configured via the CLI. If you're not familiar with command line interfaces, they can seem a bit daunting at first. But you will get used to them very quickly, and they will soon become your preferred configuration interface. Okay, to get started, I'm going to run a continuous ping to the MTS switch. Currently, the switch is in factory default, which means it has no IP address. So, of course, there will be no reply to the pings. But this way, I'll know when the IP address has been configured successfully on the MTS switch. Now I'll start the terminal emulation program. As I mentioned before, I'm using Teraterm. I'll connect to the switch via the console port, which means I'll use a serial connection. So I select serial in Teraterm. I need to specify the COM port number, and in this case I'm using a USB serial port, which is COM9 on my PC. When I press the Enter key inside the Teraterm window, you see the switch prompt. You also see some text in bold. The bold text consists of event log entries from the switch. By default, these event log entries are output to the console port. It's possible to disable this, but I find it quite a useful indication of what's happening. You'll see more of these log messages later, and I think you'll agree with me. Here's a list of available commands in the common user mode. These commands require only the minimum administration rights. Next, I move to the privileged user mode. You can see from the log message that my rights have changed from user to administrator. Let's see the available commands. Okay, now let's enter the global configuration mode and view the available commands. There are a lot of them. You don't have to learn them all. You just need a few to get started. And as you develop more complex configurations, you will learn more commands. To use the console port, you have to be present at the device. This is not very convenient, so we need to configure remote access. To give the switch an IP address, I first need to change to VLAN 1. Always keep your eye on the event log messages. They provide interesting information. Now I'll enter the IP address and subnet mask. Watch the command line window to see what happens to the ping requests. Okay, the pings are getting a response, which means that the IP address is configured correctly. To access the switch remotely, the switch needs to have a password. So I'll configure it now. Using such a weak password is very bad practice, but it's okay for this demo. Before I configure any communication protocols on the switch, I want to show you what protocols are available by default. To do this, I will use Nmap with the ZenMap graphical user interface. In ZenMap, which is a graphical user interface for Nmap, the command input box can be used for standard Nmap commands. The text you input is what you would type if you were running Nmap from the command line. Under Profile, there are a lot of predefined commands, but I just need something simple to see which TCP and UDP ports are open on the switch. Dash lowercase s, uppercase s, means scan the TCP ports using only a sync. In other words, don't perform the TCP handshake. Dash lowercase s, uppercase u, means scan the UDP ports. In both cases, only the first 1,000 ports will be scanned. As this is a low priority scan, it will take about 20 seconds, so I'll move the video ahead. Finished. So, what can we see? The scanned MAC address is from Belden Hirschmann Industries Suzhou, which is correct for the MTS switch. There is one TCP port open. Let's check the summary. The only open port is TCP port 23, which is used for the Telnet service. No other ports are open, which means that no other communication services are running. To use other services, such as SSH and HTTP, I need to configure them. It's unlikely that you will always visit a switch in order to manage it. So now I'll enable some remote access protocols. Let's start with SSH, which enables a command line interface from a remote location. Unlike Telnet, SSH is encrypted, which offers greater security. It's not necessary to type the complete command word. To save time, you just need to type enough to make the command unambiguous or unique. In this case, EN uniquely identifies the command enable. The password, as you know, is private 123. Conft is the equivalent to configure terminal. A few commands are required to configure SSH. I'll configure the function for the admin user. In this case, I'm configuring the SSH service. During the first login, the user will be required to change the password. So now I'll configure a temporary password. Privilege 15 is the highest privilege level. The remaining configuration is the same for all 16 possible remote connections. This line disables the login timeout. For live operation, you should keep the automatic timeout. I'm just disabling it for this demo because it's more convenient. This enables AAA checking for the login. Finally, I enable the SSH server. I don't need the ping check anymore, so I'll close it. Even though I will now use SSH to connect to the switch, I'm going to keep the serial link to the console port open. This is because it's useful to see the event messages. but the messages are not so easy to read, so I'll change the font. Okay, let's make the first connection to the switch using SSH. We'll still use the Terra term, but this time I'll start a new session using SSH. Terra term needs to be configured with TCP/IP, the IP address of the switch, and the SSH service. In this case, the IP address is already present because I've created an SSH session to this switch in the past. The username is admin. The passphrase is the temporary password I created earlier. You can still see it in the Terraterm console window, temp password 123. As I mentioned before, the user has to change the password on first login. I'll change the password to private123. And I'm connected using SSH. Note the event in the console window. I'll just tidy up a bit. The first thing I want to do is disable Telnet. I don't want unsecure protocols active on the switch. Done. To prove that Telnet is disabled, I'll quickly run another Nmap scan. Now you see that the Telnet port 23 is no longer open, and the SSH port 22 is now open. Next, I'll enable the graphical user interface of the switch. On one hand, the MTS is an IT switch, which is intended to be configured using the command line. So the GUI is quite limited. On the other hand, I find the GUI useful as it provides an overview of the switch status and the configuration of ports and VLANs. I'll move a bit more quickly through this part as you've already seen the principle. As I said before, I do not want any unsecure protocols on the switch. So just note that I've enabled the secure version of HTTP, in other words, HTTPS. Okay, let's take a look at the GUI. Here is a user-friendly overview of the MTS. I like to see which ports have a connection, and the status of components like the fan. I'm not going to go through every screen in the GUI. I'll pick a few which provide a good overview, even though some of the functions are not yet configured. Just pause the video if you want to take a closer look. Of course, you will want to manage the MTS switch, and for that we need SNMP. In keeping with the principle of security, I will use SNMP v3. I just need to make some space on the desktop. So far, you've seen me typing commands into the CLI. You also saw me using abbreviated commands. So now let's look at a third technique which offers a convenient way to avoid a lot of typing. What you see here is a text file. It contains a list of commands. You probably recognize the commands I've been using so far. As you can see, a few commands are necessary to configure SNMP v3, and I don't want to have to type them. So instead, I can use copy and paste. I copy the commands from the text file. And paste them into the switch CLI. So much faster. Regarding the commands themselves, just note that I'm using authentication and encryption and the now well-known password private123. One other thing, notice at the bottom of the SSH terminal window that the switch prompt was previously switch and now it's my MTS 2624. I want to show that the SNMP v3 is now operational. I could set up a network management application, but for the demo, it's quicker and clearer just to do a MIB walk. This means I'll retrieve the values of MIB variables directly from the switch. In this case, I'm using a free-of-charge SNMP MIB browser tool. The first step is to configure the SNMP v3 settings. These need to match the settings I configured in the switch. I need to add an SNMP v3 entry for the switch. I'm using both authentication and privacy with the familiar private 123. Good. Now I'll make some space to move down the MIB tree. Let's do a walk on the system group as it contains some parameters which we changed earlier. You can see the contact, location, and system name, as well as information about the switch itself. So we know that the SNMP is working correctly. Every network administrator needs to know what events are happening in the network now and what has happened in the past. In IT networks, and increasingly in OT networks, a Syslog server is used as a central repository for log messages from all devices on the network. This ensures that all messages are held in a single location and can be collated. Enabling Syslog is just a single command. Of course, the function can be fine-tuned to define what information is sent to the Syslog server. But for the demo, I just want to show the basic function. So I just enter the source of the information, which is the switch, and the IP address of the Syslog server. Now I'll test the function. First, I open the Syslog server and clear the old messages. Now I'll disconnect the device which is on port 23 of the switch. You see the link down log message in the Syslog server display. If you compare it with the event entry in the console window, you will see that both entries are the same. Now I'll reconnect the device. And there is the next link up event, most recent at the top. Link Layer Discovery Protocol, known as LLDP, is an open, vendor-neutral protocol that allows network devices to advertise their identity, capabilities, and neighbor information on a local area network. The information provided by LLDP can be read back from the devices by network management systems and used to build an accurate topology map. LLDP is simple to configure. To save some time, I'll copy and paste the commands to enable LLDP. I'll use a network analyzer to check whether the MTS is sending LLDP frames. I select the Ethernet network adapter because I can see there is activity. I'll filter for LLDP frames. LLDP frames are sent out every 30 seconds, so let's see how long we have to wait. There is a frame, so I'll stop the capture and take a closer look. You can see that the source MAC address is Belden Hirschmann. Let's expand the frame. So the frame was sent out of port 3. The system name is MyMTS 2624. The rest of the information is correct. So LLDP is working fine. On the topic of topologies, I want to enable spanning tree protocol. Spanning tree is primarily used as a redundancy mechanism to identify and resolve loops in a network. Even if you don't use redundancy in your network, it still makes sense to enable spanning tree. Spanning tree will disable any loops which are accidentally created. The MTS uses multiple spanning tree by default, but as I'm not using any VLANs, I prefer to use rapid spanning tree. As described, I change the mode to RSTP, then enable the function. Again, the easiest way to show RSTP working is to use the network analyzer. This time I filter for STP. There we go. A frame every 2 seconds. The source MAC address is Belden Hirschmann. The spanning tree version is Rapid Spanning Tree. So the MTS 2624 is now configured with some basic settings. For sure, your network will need additional configuration, but now you understand the principle. There is one last extremely important step which you really should not forget. You should save the new configuration so it's still active after the switch reboots. There is nothing to it. Just copy the running configuration to the startup configuration. That's it. To finish off this series of configuration examples, I want to show you one last tip. This is how IT professionals configure switches. To begin, I'll put the switch back into factory default. I don't need the SSH terminal window anymore, so I'll close it. I'll complete the following steps. Go into Privileged User Mode, delete the startup configuration that we saved earlier, reload the switch. Do not copy the current configuration to the startup configuration, as I want the switch to be in factory default. It takes some time to restart the switch, so I'll fast forward. Good. The switch has rebooted in factory default. Let's ping it to make sure. Now, you remember the script file that we used earlier? You may be thinking that you could just open it, copy the complete text, and paste it into the console window. And you would be right. But there's a quicker way. Just grab the script file and drop it into the console window. Confirm the paste action, and you are done. It takes around 10 seconds to configure the switch, including the time taken to start the services. That brings us to the end of the configuration examples. For your own network, you will probably need more configuration, but you should now have a good understanding of the command line interface. And I'm sure you appreciate the speed and simplicity of using commands and script files to configure the Hirschmann IT MTS switches.